Well, great. I guess we'll go ahead and get started. So thank you all for coming to our June meeting. We're back in the library, as you can tell, which I think is a much quieter and easier place to be. Okay, so plans for the day. We have the recent space news that Greg's gonna go over. And then we'll have Chris come and talk about the NASA Hunch program, which is a great way to get high schoolers actually involved in the space program and actually doing some real design work. And then at the end, I thought we would do some brainstorming. So I was going to put some stuff out after that, but got distracted. We could talk about kind of elections and also some time for social life. So that's the plan. With that, let me go ahead and pass it off to Greg for the space news. I'll just switch over to his presentation. And there
you go. Okay. Yeah, thank you. All right, well, welcome. I'll start off with the space news here, covering roughly a month. And there are a few things that went on. One of them is the Chinese announced that 3 more astronauts, tagonauts as they call them, up to their space station. And this is pretty much what it looks like right now. There's a core module here in the center. Oops. The center area. That's about 14 feet in diameter. The whole thing with there's 2 cargo capsules right now on either side of it. So those come along and get reproduced periodically. But typically there's going to be 2 in place. The whole thing is 20 feet long. The spacecraft that takes them there is down on the lower portion, lower center portion of the line here. That's their crewed spacecraft where they come up, so it joins in. Now, in the future, in the next 6 months, while these guys are up there, they're going to be adding 2 more modules. And they're going to go in, there's going to be kind of a T-shaped station. Basically, the place where the spacecraft joins up with the main module, there's several other ports there. There's the docking port on the far side, but then there's 2 more. And so they're going to have sections of the station coming up here. And that'll be the sort of version 1 of them. Essentially a full-size station, where they can go to more. But at least for the near term, they'll stick with the 3 modules. So a few other items on there. There's a robot arm, kind of like the Canada arm we have on the space station. You can't see it that well in this drawing, and I'll just set it out. And when they add the 2 more modules over here, they also will come with robot arms. So there's actually going to be a total probably 3 robot arms up there for grabbing things in space. So anyway, they're moving along. This is all new stuff, and they're looking for international partners. I'm not sure how hard they're looking for people to come up there, but they say long term they actually are international. More close to home news, the Boeing Starliner, which is the second way that the NASA is hoping to get to the space station. They finally have their unmanned test where they blast it off. It was on an atmospheric rocket. They go up to the International Space Station, unmanned. Make sure that it works. That people there went inside the capsule and looking and so on. 5 days later, they came back and they parachuted back down to Mexico. This has been waiting for a long time. Remember, this is all funded originally by NASA. 2 different companies were awarded a commercial contract for getting people to and from the space station. SpaceX, they've been doing this for quite a while. Boeing is trying to catch up, but this is, they're late, but this thing are coming along. And they have some problems along the way. They have membrane thrusters, 2 of the 12 failed, but they had enough of them that it didn't matter. They just were get things done. And there were 2 smaller thrusters. I'm not quite sure what they were, but I think they're mainly for use at the very end during the time. The maneuvering thrusters are the bigger ones. They have trouble, but anyway, there's no redundancy. They were saying, well, probably never really know exactly what happened with those thrusters that failed, mainly because they're in a service module, which is exposed. That's why they won't be fun. They also did have some minor glitches in the cooling, and also in the docking procedure. They had to do it several times that didn't quite do it the first time. And actually, the crew and the ISS, so they got it done. Better late than never, I guess.
And
Okay.
so it's really this is like the first American craft that has pumped down instead of splashed down, right?
I guess that's true. Well, we'll know.
Yeah.
Yeah. Okay, so next thing, James Webb Space Telescope. Now, this has been going on for a while. We've talked about it before. It is still on schedule. They are saying they'll release full color images on July 12th. So it's coming pretty soon. Yeah. You know they're trying to hold back and have some really spectacular. You know, in the meantime, though, they did have some glitches, or not glitches, problems. Remember, they have these hexagonal mirrors, they're about 4 feet in diameter, there's each in total. They got hit by a micrometeorite. We're talking about something the size of a grain of sand. And so, and this will happen. They had anticipated, of course, that there's dust up there. It's going to hit it. And they said they have been hit 4 times before this. And they were pretty sure they could handle that. This was a little bigger than they planned for, but really what it meant was they couldn't test for anything bigger. You know, because the thing is, although it's a tiny little grain of sand, it's going very, very fast. That was something they couldn't really test for. So what they've done is, you know, these mirrors are all quite adjustable. They've gone through a procedure already, and they did some big adjustments, and they can compensate mostly for the solution. Apparently, it won't be quite as good as it might have been. But what they were saying is it's still better than the specs anyway. So, you know, there's no real loss. Now, over time, though, they're saying now things will gradually degrade. You know, there is stuff around out there in space. They apparently have a way, if they know there's a big cloud of dust coming for some reason, they can actually rotate or somehow turn the mirrors so they're protected better. Okay, next thing is the update is on the spacesuits. There's really several different kinds of spacesuits. You know, there's spacesuits used in the space station, and there's also ones that were we needed for going to the moon. And both of them have been problematic as of late. Now, the moon spacesuits, I don't know if you remember, but last year, NASA Watchdog Group flagged that, you know, these spacesuits were not going to be ready in time for the original Artemis landing on the moon, which was scheduled for 2024. And they just said, okay, that's it, you know, forget about that. Well, obviously that wasn't going to be the right answer. So NASA went back, and what they decided to do was something very much like what they did with the commercial crew program. They said, okay, we're going to hire 2 private contractors. They're going to essentially compete against each other, and they're going to each make their own set of spacesuits, and they will have to deliver them by 2025. And it's a good thing because there's both of them are needed now. The moon suits simply weren't there. You know, there are no such things anymore. But actually, the ones on the space station, the ISS, they're in trouble too. Right now, they've halted all use of the spacesuits. The problem is that they're having these problems like they've seen a long time ago, where water starts accumulating inside of them, you know, like where you breathe. And they had made some modifications a while ago to help with that, but there's still a problem with it. So right now, they're saying nobody's even allowed to use these spacesuits unless it's a dire emergency, and they really have to. Keep in mind, these things are literally over 40 years old. I mean, the newest one is 40 years old, and there's older ones than that. So, you know, they're not exactly in the freshest condition. There's really, out of the 40 they had, there's about 18 that are still good. So this is an expensive program, $3.5 billion. That's actually more than NASA is spending for the lunar lander, you know, the human landing system. But on the other hand, this is a long program to cover both the space station, and the moon, multiple trips to the moon. So the 2 teams that are picked, they're actually based both here in Houston. One of them is Collins Aerospace, who has done spacesuits in the past and will continue doing so. And then Axiom Space, they're the people building space station. They were well underway in having their own ready anyway. So this was kind of an easy thing for them. And of course, Collins is probably involved in the previous efforts, so they have a lot to do as well. Yeah, that's right. Ah, okay. So anyway, they're going to spend 3.5. It's really up to 3.5 billion. It doesn't necessarily have to be that. They have performance guarantees. If they don't deliver spacesuits, they don't get paid something. They do get something. The terms were not really all that tightly spelled out, but the main thing is 2 competing teams, some guaranteed minimum, so that to get their interest going and get them started, and then performance after that.
Was there maybe not like jumped out of County and asked about water, like where did the water come from? It had to be cooling. It had to be cooling system somewhere somehow. Like how did it get up to us now?
I don't know. It was more like maybe put something. Not sure they were really solving it.
Thank you.
The real answer is we don't really know. But maybe the real answer. You're out there in space and you're not just get back and sort of kick in air again. So, pretty scary thing. Now, the business model was actually again kind of commercial crew. If you want to think of an analogy, think of it as renting expensive tuxedos. It's kind of like that. They're literally renting the spacesuits, but this way they have the freedom. There's private space stations. They can sell them or rent them to anybody who wants. The key is getting the government out of the business of simply buying them and holding them all on their own, turning it into a space stuff as a service. And as opposed to basically selling space.
Hey, Greg.
Kind of the way we did in the past. You think with space.
Hey, Greg.
Yes.
We can only hear you if you're facing the camera. We can only hear you when you face the
It
camera.
must be the microphone is okay. I see. Okay, sorry. What I'll do is switch. Okay. So anyway, that's the business model is going over to more of a private one. They obviously have some requirements. One of them is that the spacesuits have to fit from the 5th to the 95th percentile in terms of size and the population. They've had a problem with that. If you're small or large, you might not even have a spacesuit that works for you right now. As I said, they'll be available by 2025, which is just the time you need for Artemis 3, which is the first human landing that's part of the Artemis program. Now, independently from that, SpaceX is developing a spacesuit, but theirs is really only for spacewalks, things outside. And they need that fairly soon because they have all these programs planned for people to do just that. But it doesn't include the moon. Designing one spacesuit for everything is not completely an easy task because in a weightless environment, actually your legs are kind of useless. You don't really need them much. Whereas if you're going to be walking somewhere with gravity, like on the moon, you need to be able to walk, you need more flexibility. You need to be able to bend over. There's a lot more issues. Well, plus the dust and everything. So apparently the way both of these companies are going, it's kind of a modular approach where there'd be a core that's usable everywhere and then different parts would be used for the moon. Okay, it was an interesting demo that got a lot. It got kind of hyped by NanoRacks, another local company here. General goal is they want to be able to do construction in space. And that includes disassembling stuff in space. So for instance, if you want to get some metal, this long range picture, you want to get some metal, you go out and cut up an old upper stage rocket or something, turn it into a habitat, whatever you need to do, cutting and welding and so on. So the very first step here is just doing cutting, and which doesn't sound like it's a big deal, but it actually kind of was, because for one thing, in normal cutting, imagine you have a circular saw or something. You're shooting out all kinds of pieces of metal, basically, shooting off. Not a good thing in space. That little grain of sand, damaged the James Webb Space Telescope. Same problem. Anything going 17,000 miles an hour in a slightly different direction than you're going, and you've got trouble when you get hit by that. So that matters a lot more. So they came up with a technique that's basically milling, just meaning, normally milling is rubbing, but what they do is they just go to really, really high speed, and somehow they figured out that they can do this, that basically just melts the metal as they cut through it without sending off sparks. Now that was a theory, and apparently it worked on the ground, but the question is, would it work in space? And they're testing it. They had 3 different coupons, different metals. The main one of interest was 316 stainless steel, which apparently is what the Vulcan Centaur rocket is using. Not that different than SpaceX, I guess, if you get do it. The whole thing was about a 10-minute demo because what they do is they have a robot arm with a milling end attached to it, built by a company called Maxar. They run the thing for 10 minutes, do the cutting, and then the thing is it's attached to the upper stage of the Falcon 9, which after an hour, they give them 1 hour. After the 1 hour is up, they're going to deorbit the thing and then it'll burn up. So they had that time to do the experiment and then also transmit a video. So essentially the result of the experiment is present the video, and then put some nice words around the video. So anyway, the goal though, as I said, is they have a whole program for advancing space manufacturing. This will involve assembly as well as building and cutting. So what happened? Well, they did launch. Transporter 5, this was the most recent of the SpaceX missions, which is a lot of small satellites all packaged all together. They went up in this last month and they did the test and they tweeted out saying, this is great, we're up here, we're going to do the test now. And they haven't said anything since. So probably it didn't go completely as planned is my guess, but we would have heard by now. It's been a couple of weeks. So I'm still hoping that maybe something came out of it, but it may be they're going to have to do it. Yeah, that was the official mission pass. I think that the little coupons they were cutting might have looked pretty much like that as well. Pardon? They didn't actually specify. Maybe they didn't really specify that. I mean, they just said it's a robot arm with a milling end, so it's basically something that looks a lot like a saw, but it probably doesn't have teeth. It's just something that spins really fast and somehow with friction, it just melts the metal rather than has pieces flying. It wasn't that clear how that would work. I don't think there's.
Yes, stir well. Yeah, friction stir well. Yeah, and it uses a little disc that's thin, very high speed, and then it just cracks right there in the joint where piece of metal just push all that on it, and it smears. It's like smearing better. Barely works.
It's sort of the reverse of that, but anyway. I didn't find any details of exactly how it's done. They just said it's a high-speed milling, and they just said it'll work somehow or other. So anyway, we're still waiting to hear the results of that, obviously. The Lucy asteroid mission, we talked about this back when it launched back in October last year. This is the one that's going on a mission over the next 12 years. It's going to really 3 sets of asteroids. There's the Trojan so-called Trojan asteroids, which are the ones that are trapped around the Lagrange points in front of and behind Jupiter. They are places where its gravity is stable enough that things tend to accumulate. And so there's asteroids that have accumulated there in those 2 spots, plus a few others. This mission sends this probe called Lucy out to visit them over a 12-year period. It's a really long period because to do all the visits they want, they actually make 3 flybys of Earth as a part of the process. Each time, they're coming by Earth, and Earth pulls it a little bit and gives it a little bit of a gravity boost. So that's how they're getting by with very little fuel. Now this is interesting because it has solar cells. Usually the deep space probes like this typically have some kind of nuclear heating source, and rather than solar cells, they went with solar cells. And you can see them here. To be able to fit into the fairing and nose cone of a rocket, they have to be all folded up. So they're on these long poles, which probably are folded inside the rocket. They open out and then they unfurl like a fan. They unfurl the solar cells and they found on both sides. And there's 2 sides. So the one on one side, pretty much that's probably almost closed. It actually finished as a latching for that occurs at the very end, and they go, phew, we're done. One of them didn't quite finish. It didn't quite latch. And they've known this for a while. They've been working on all kinds of simulations and analysis, trying to figure out what's wrong. And they concluded that somehow or other there was just too much slack. They have a motor that essentially you can imagine pulls cables, which tend to pull these things around. And somehow or other it got too loose and it got wrapped around a motor or something. So that they're not, of course they can't see it, but that's not really a hypothesis. What they've tried several times, and during May in particular, what they did was they have the the normal motor that does this unfurling, and they have a backup motor. And so they tried running both of them in parallel to get more force and hoping nothing would break in the process of doing that. And they said they managed to get it a lot closer to being latched, but not quite. Now, what they think, though, is that even if they don't manage to get the latch, just keeping the tension on the cables that are there is probably good enough. They say they're getting, I forget if it was 80 or 90%. They're getting most of the solar power they need anyway. And that's mainly only a problem when you're out as far as Jupiter. I forget the exact numbers. When we did this the talk about the original launch back in October, it was something like 1/10,000th of the light is available out there as opposed to here, but that was still enough. There's a lot of power right now, but when they're out of Jupiter, that's when they really need everything. Okay, miscellaneous items. Blue Origin did another suborbital flight, 10-minute ride up and back down. And then kind of a fun one here, NASA is commissioning a small study to review unidentified aerial phenomena. They've changed the name from UFO. It's a more general title. It probably makes sense because it might be a phenomenon, not necessarily an object. So they've covered that. Obviously there's been interest from the military and people, all types. It's going to be a 9-month study. And what they're going to do is they're going to issue an unclassified report at the end. Now, the purpose of the study isn't really to go and definitively say this was a UFO and this wasn't. I'm not going to do that. What they're going to do is first they're going to identify where is all just the source of data, because it's in a lot of different places. I mean, commercial pilot sightings of things, military and so on. Just identify it. Figure out how to collect the data in a more organized way going forward that everybody can have access to. And then figure out just how to use it and how to make real decisions. So you're not going to see a report one way or the other in this 9 months saying, aha, there's no such thing or there is such a thing. You're simply going to say, here's a way to have an organized program. They're going to spend up to $100,000. So that tells you right there, it's not too expensive a program. A few people working for 9 months. But it's kind of interesting that they found it necessary to do that. Okay, talking about how many launches. How many launches have there been since the last meeting, which is around May 14th? How many? Well, that's better than your million guess from last time. You're closing in. Well, you're a lot closer. I have to give you that. Any other guesses? You're getting really close now. Okay, how many think there were more than 11? Okay, well, sorry. No, actually, it's only 10. Is the answer here. Yeah, I think somehow between the economic problems and COVID and everything else, things have really slowed down a bit. Oh, there were some substantial ones in here. Of course, you have the usual, SpaceX putting up Starlink satellites. You're always going to get some of those. Although it's interesting, they Musk has said that really for that service to really make money, they have to have their newer, bigger satellites up there, which won't fit in a Falcon 9. So they really need Starship to do that. So they've already kind of said they're not really going to be really good until everything else falls in place. You can actually launch satellites. Okay, Chris already talked about the Boeing Starliner, and that went up like that. The Russians launched a military spy satellite, and the Chinese did a few of that sort of thing. The Falcon, the Transporter 5 mission we mentioned already. This is a typical thing where SpaceX just accumulates a whole bunch of all small satellite jobs, sends them all up. Now, there's trade-offs on this, and we've actually talked about this before. But they're going to take you to one orbit, which is typically a polar sort of orbit, and a lot of little satellites. Well, maybe all those satellites don't all want to go to exactly the same orbit. So the way they do that is there's 3 separate companies that have little space tugs built in there, and what they do is they spin out. And then each one of those in turn can move around and deliver satellites to different orbits. And that's kind of how the economics are shaping out. It's still a lot cheaper for companies to do that than to launch on a smaller rocket. But, it does mean that there's a lot more dependencies on, having exactly this kind of ride. Rideshares in general, that's the name for taking a small satellite on a big satellite launch, has caused a lot of scheduling problems recently. Every time a big satellite gets postponed, which happens all the time for various reasons, all the little ones who are going to tag along all of a sudden have to reschedule. And sometimes, if it's just a low Earth orbit kind of a thing, it doesn't really make much difference. They can easily absorb that. But sometimes the missions were, for a long range, like the Psyche mission, which is the one that's going to look at this giant metallic asteroid and potentially do some prospecting there. That got postponed until September. Well, there were some ride shares that were going to go along with that. They were going to go out and look at some other asteroids. Now they've got to reschedule those. And so scheduling is getting. An interesting one, Doug, you'll like this because you thought it was funny last time. Geely, which is a Chinese car maker, is launching satellites. This time they succeeded. They put a bunch of them up there. The reason they're doing it is something to do with autonomous driving. They want to be able to use it for one for distributing software and so on, it's just their network. And the other thing is for navigation as well, instead of GPS. So all these things they're tying their future automated car, autonomous driving, really to the satellite-based system. The Russians launched a cargo ship space station. I already mentioned the astronauts going up. Then the last one here is just an Egyptian telecom satellite, which sounds pretty routine, and it is. But what's interesting is this was the first commercial launch to geo kind of an orbit. Normally, in the old days, the bread and butter for rocket launch companies was sending these big satellites up to geosynchronous orbit, doing things like they're broadcasting TV or whatever it is they're doing. There's not as much of that anymore. Most of the activity these days is low Earth orbit. The kind of things like Starlink and OneWeb and so on. So the fact that it took this far into the year to even get to that kind of a launch is kind of interesting. Now there have been others. I mean, there have been military launches and that sort of thing for spy satellites. But this was a commercial. Okay, any other comments or questions?
One of the flights were SpaceX, and I guess one of them wasn't.
Yeah, it's pretty much. I mean, this is the people that put up most of what goes up is there. The Europeans come in periodically, then occasionally you get a Japanese or Indian one or something. But it's pretty clear the main space powers of the U.S. and China. I think what will happen is the Russian program is really kind of falling by the wayside here. You're going to see mainly military satellites or still supporting the space station. I should have reminded that cargo ship. They are still supporting the space station. They actually are keeping their agreements that they will continue to do. Yeah, the windbag, yeah. Oh, they probably have these signs and stuff.
The one thing that I am noting that by its absence is one thing I'm noting by their absence is the small rocket launcher companies, which I was under the impression that they were going to really be pressing forward strongly by this time this year.
I thought there would be more of that too. Well, the thing, Rocket Lab in particular is the one you'd really expect. And they're held up to some extent by procedural kinds of issues. I mean, they have their Wallops Island facility, which hasn't really been fully blessed by the government yet, so that can't quite take off. Some of the missions actually weren't quite ready yet anyway. But when you get down to it, the economics still favor SpaceX with these transporter kind of missions. Putting up a lot of stuff at once is just cheaper per kilogram than the smaller ones. What their big advantage is, if you're a small launcher, is going right to the orbit you want. And the problem is all these little companies that are making the Sherpa and all these space trucks, they're actually kind of cutting into that business. I mentioned there were three. I should have said something more about that. One of those was from a company called Momentous, which has had all kinds of financial problems, and even people questioning whether they're really a real thing. They have an exotic propulsion system based on microwaving water as a propellant, a little different, a variation on an ion engine. One of the companies, I can't think, Star something. They actually broke off. Well, SpaceX broke off their contract with them, so they're no longer going to deal with them. They'll finish out the missions, but they're not going to do any more. Anyway, no. Most of all these, I just say a lot of these smaller loads, they get pushed back. Yeah.
They were working on, they were changing the amount of reuse they were trying to get out of Falcon 9 from 10 to 15. So it was really in depth. I can't remember the name. I think he was an ex-NASA guy. Yeah, it's on the internet. I'm looking up, but they're using all the data they're getting on the reuse, right, to figure out all their parts that change. And they're using all the Starlink launches for their fleet leaders. They're the oldest, but they're it's not somebody else's deal. But they think they're going to be able to be certified in 15. So that's pretty good.
Yeah, I mean, that's really usability and drop the price even further, at least those potential users.
So it was a really good, it's not, I think it's about 40 minutes. It was really in depth on the work they're doing, how they build, and I'm a computer programmer, so unfortunately I don't work in space. They're using all the data. They built their own internal management system in SpaceX so that all that data feeds back in, programmatically as they're tearing that stuff down to help them increase, their reusability.
They got to go right down the component level to see which nuts both the screws fail the fastest, in which location, and then start easing those up. The lifetime, the reliability of the rocket.
And the guy that I wish I could remember his name, but the guy that did it, I worked on a shuttle program, and he was talking about the key to rapid reusability and getting that kind of stuff in there was once you've tested something, you have the data to prove that you don't need to refurbish it, or you don't need to inspect it, you drop that procedure. And he was talking about how with the shuttle engines, after they take them down and tore them down so many times, they're like, okay, we know what's going on here, but it was like, oh, we got really good at doing it, so let's just keep doing it just to be extra safe. Bring it up, people, right? So you can't play around with that. But I just thought it was an interesting conversation, and the fact that they were moving 15 from 10, that was really eye-opening.
Yeah, they're just interesting. They were talking for a while there about recovering the nose cone, the fairings, and they still are, but they're just letting them drop into the sea now and recovering them there. They decided that just use better metal and it won't corrode that much.
U.S. government giving SpaceX permission to launch again out of Boca Chica.
They keep the EPA has been the problem here, and they keep postponing it and postponing it. They keep saying a couple of weeks, and it should be right around now. Actually, was where the next result was coming. It's a, yeah.
February 15th.
Yeah, they just it kept rolling. It was a rolling date. It's always N plus a month, whatever. Yeah.
Items on the checklist, and they're still have one outstanding. Instead of losing our market for 2 weeks. And on this one, they finally took that last mile. Fingers crossed.
Now we'll see if SpaceX is actually ready, because they keep changing it in the meantime, and they've already changed out the engines and all kinds of things. So.
Based off the original schedule, the permission starts flying. I think we're 15 that now they get a situation where they've got to slow down the work. They've got to slow down their assembly line on building rockets because they're running out of space to put rockets, completed rockets on that facility down there until the government blocks the data.
I don't know how
Oh yeah. Oh yeah.
Well, they had the thing fully stacked, a while ago, and then, but actually, I think they've changed. They meanwhile disassembled it.
Hey, Greg. Greg?
Yeah.
Could you repeat the questions? We can't hear any of it online.
Oh,
Can
okay,
you
sorry.
repeat the questions? We can't hear any of it online.
Yeah, just a minute. Yeah, the question has been just the SpaceX status with, you know, the government approvals and so on. We're still kind of waiting and speculating that actually even SpaceX may have some trouble at this point. They've changed it so much. Okay.
Going on vacation next week, so I'm pretty certain that.
So can they hear that, or is, can the remote users hear you on that microphone?
I mean, it's not.
Can.
Oh, okay. He's just saying Eric Berger went on vacation. He normally reports on this stuff. But does that mean that he thinks it's not going to happen, so he's free to go on vacation, or?
No, you didn't see.
Okay. All right. So I think time to move on to the featured speaker.
So,
Here's Cap.
hey, Greg. Hey, Greg.
Consult. Oh, yeah. I hear their question.
Yeah,
here.
real quick. Did you hear anything of the impact of the thruster failures on the Boeing Starliner?
Okay. The question was, did we hear
Have you heard
anything about the impact of the problems like on the thrusters with the Starliner? No. Nothing more has really come out that I've heard anyway.
Okay. Yeah, it's been pretty quiet.
Yeah. And it sounds like, from what they're saying, they're saying it's going to be a little, they're not going to be able to examine them. So it's going to be a little hard. They can look at data. They probably have some things to look at. Maybe we're not going to have a definitive answer. They'll just keep pointing to the fact that, okay, they have redundancy built in. Anyway.
Markedly improves the goal, NASA's goal of achieving two different companies be able to provide data access to space.
Yeah. So bottom line is NASA,
Very close.
NASA thinks they passed the test. So it's good enough. You know, I mean, everybody has some glitches like that. As long as they can really convince themselves that it's minor, apparently they have. They're going to go ahead. Okay, so Chris, actually, his background is more turbo machinery and that kind of thing. He's a professor also in doing consulting, doing both things. Got involved in starting new ventures in places like India. Went to school in Germany in mechanical and aeronautical engineering. And he's going to talk about the Hunch program, which is where high school students get to design stuff that actually gets used by NASA, mainly in the space station. So here's the program.
Yeah, thank you very much for your introduction. Nice slide. So within National Space Society, we what's called the Space Society. So we discuss not being on the first. No, that's not the role. That's not the role. All right. But it's a select group of people that NSS has selected. To talk more and more frequently to the public about space. And anybody can join. And I'm sure
Hey, we really can't hear anything online with them over there.
Would you mind if we switch over here? You can talk to them too. And I kind of
absolutely.
maybe do that.
Hi, everybody.
Yeah, it's better. Thank you.
Okay, perfect. So anybody who'd like to join there, absolutely welcome. We can use more people to talk about how we're going to settle in space, right? So let's talk about Hunch. This is a great program that almost nobody has ever heard about. So I want to explain here what Hunch is all about. Let's see here. Okay, so Hunch. What does Hunch stand for here? So Hunch are high school students united with NASA to create hardware. It's one of these wonderful NASA abbreviations, right? You got to just love them. Been going on for a very, very long time, actually. And there are lots of high school students working on official NASA programs. And they get to design, they get to build, they get to make stuff for NASA. So how many students or schools or objects do you think they've actually made? 5,000? 5,000 would be more right. So let's look at that a little bit by the numbers. So 277 high schools at least, and I know that number's a little bit out of date. Working with NASA centers. So the key areas they want to focus on is engineering, machining, prototyping, food science, yeah. Astronauts need to eat food, communications, and even software development. Over 642 items have been produced, and more than 1,300 have been flown to the International Space Station. And that statistic is actually from 2017. So there's probably 1,000 more items out there. Yes, sir. Houston actually has at least 6 or 7 schools working here with Clear Lake. Yeah, that's where they're all distributed, right? At least on Earth. And let's see what they do. So we see students making cargo transfer bags. Okay, that all needs to be done, and those are not your bags that you pick up at Kroger, right? They got to be made out of more sterner stuff, so there's a real specification attached to that. They do computer-aided design. Actually, a majority of the schools working on the program, they actually get CAD equipment given to them by NASA. Right? Here's software. So a whole team of students came up with what they call the tool location app. So they can figure out where the tools are all hanging out inside the space station. And a big part of the program too is coming up with new menus that the astronauts actually like to eat instead of what they're forced to eat, right? So some more items. Okay, a link catcher. That, I mean, obviously those are things you need to have because there's a lot of dust inside the space station. Storage lockers. All the storage lockers and all the cargo transfer bags on the International Space Station were made by students. Yeah, and this really sounds good. Orange, blackberry, croissant, casserole. I mean, maybe you want to be an astronaut after all, right? Didn't eat that kind of food. And also other things like handrails, support equipment, et cetera, et cetera. Now, all of these things are just not made. They have to be done to specification. It has to be space sturdy. So there's a big design and specification effort to actually get it right, even for things that you'd say are not mission critical. But clips. There's a circuit board inspection table. So that's a little bit more advanced, right? And more transfer bags. Honest to God. So this is actually a serious effort to reduce costs, but more importantly is to engage high schoolers to, become the next generation of space engineers. Right? Nobody's ever heard of it, right? I think so too. Yes, sir. Well, right now it's all through NASA, but now with privatization of space, I think other companies should be getting on board, right? And so some of the partners already there are NanoRacks, Lockheed, Jacobs, Boeing, and Raytheon. And it really is all schools here right now. Now, I guess that's what's called Hunch High Schools, but why couldn't NASA open that up a little bit, right? Now, there are organizations, wonderful organizations outside of Hunch that are doing incredible things. So one of our space ambassadors recently did a presentation on his effort in Florida, where his middle school, you're all sitting well, middle school, sent up CubeSats. Middle school. So the sky is actually the limit for these kids, right? I mean, this is not rocket science anymore, right? But we're certainly looking here for more people here to join in there, because I think this is really, really worthwhile. We have more schools, more projects going on, and we'd be training the next generation, right? So, interesting fun fact. So let's say you have $25 billion and you want to buy this really important real estate in space. Does it come with a kitchen table? No, it doesn't. Right? So one of the slightly more complex projects here was to design and manufacture a new galley table. Now, this is not your IKEA table that you can pick up for $100, right? This has to have a real specification. And here are the participants here. So Sidewoods High School, Clear Creek High School, Cypress Springs High School. These are all local schools right here. A couple teachers, and then we have a lot of people from NASA, right? All helping this project right now. I've got a picture here from the astronauts. We'll hear one of them talk live about their galley table. And this in particular year was the team working in Sidewoods. So that's just 10 miles down the road. This guy, Glenn, he's from NASA. These are the kids who worked on it, and this is the high school teacher who spent literally every weekend of his life working on this project. So it requires a huge amount of dedication. They just couldn't sit around the table and do things, right? Yeah, just to communicate or to eat together, right? To be more communal. Right, and also as a work table. So they had some little extensions from the wall, but that wasn't really enough for them. So as we go through the project here, so believe it or not, the entire engineering drafting was done by high school students. Now they were supervised by Lockheed, and that was an iterative process. So my youngest son, he was part of that program at Sidewoods, and one evening he came home and said, "Dad, I hate Lockheed." they changed my specifications again. I said, welcome to the world of engineering, right? Okay, so they had a lot of fun doing that. It took a long time, and it's fairly complex. Because what this table needs to do is not only does it need all these grips, but it has individual segments so you can fold them. But a key part were the gimbal joints here. So when an astronaut flies through the space station, it's better that the table breaks off the wall, that the astronaut breaks his leg, right? So a little bit of thought had to really go into that. Naturally had to be inflammable and a couple of things. Right? And here are a couple of pictures how they're building all that. Yes, they had their own machine tools in these high schools, some of them donated by NASA. So why wouldn't you be part of that program, right? They had their own CAD machines, they had their own CNC machines. All the materials were given to them by NASA. So there really wasn't any cost to the school. Obviously, inspection and assembly, right? They had to do that to a professional program. And all the parts had to be anodized, passivated, given the right color, hard surface coating. I mean, all the classic engineering activities you would expect, right? And most of these people, most of these kids were not even 18 yet. So they even had to test it because the kids thought they were done, right? And they actually went down to Clear Lake for several coordination meetings. And then NASA said, well, how are you going to test this? So they had to figure out how to test that the gimbal joints would actually work or that it was truly inflammable, right? So they went the whole 9 yards. That's what the kids thought. Right, and then it was finally launched, and this was a little while ago. So it was set up on an Orbital 6 rocket. We were actually invited by NASA. So myself and the kids and other parents, and we got to watch the launch from the bunker where the 45th Space Wing, hits the magic red button. So that was obviously a very cool experience. Now, that particular rocket almost did not make it to the space station. One of the engines did not burn fully, but there was just enough momentum to get it to the ISS. Uh-huh. Right.
Did it fly out of balls?
Well, it completed the burn a little bit too early, but it was still within adequate parameters. I think you're right. Canaveral. No, it was Cape Kennedy, right. It was a nighttime launch, which was amazing as well. All right, so they did commission that table, Thanksgiving 2016. And we can just see it here, right? And so for the first time, you can actually get 6 astronauts around the table, right? So we're going to see what they personally say about this. Well, let's have Tim Copra tell us about it. All right, so that's really nice. You know, NASA did this little clip here, actually gave some feedback, what was good, what was average, right? And just motivate the kids even more to keep at it, right? So, but there are actually even more advanced projects. And so they've now graduated into extravehicular activity tools. And the tool used on the first all-female spacewalk was this thread tool for replacing the batteries on the solar cell systems. Because up in space, you cannot afford to strip a screw joint, right? So that has to be perfect. So the high school students there had an idea, developed that. Lockheed checked it, and it was made and used on the spacewalk. Right? Pretty amazing, right?
Well, you've got here the screw points here.
And they actually had a cleaner with it as well. So with the cleaners, you would clean out the thread connections once they were open. And the corkscrews themselves provide a little bit more guidance than usual. All right, so that's actually the end of my presentation. There's a website out there for space ambassadors, and there are all sorts of topics that the space ambassadors can talk about and that you can look up there if you're interested. Any questions? Right, that's a great observation. Now, I don't know why, right? But certainly they weren't eating all just dry food there for astronauts, right? Yeah, but that was 2016. So SpaceX wasn't really flying that much yet.
Relax certain types of requirements because they are no longer so
Mhm.
constrained. Basically just get rid of whole bunches of categories of requirements. They can just let it go because, yeah, it doesn't have to cost that much anymore now.
Right. Yeah, that's probably true too. That would be I, me, and myself. Now we actually have international space ambassadors, so we have them in Italy, quite a bunch in India. Believe it or not. We have NSS has a huge presence in India. Others are in New Mexico, Chicago, all over the country. Well, well, next question, right? No, it's completely unpaid voluntarily, like everything at the NSS, and it's really not difficult to be a space ambassador. You have to do at least 2 presentations that get critiqued by the space ambassador board, and do at least 2 every year to keep up your certification. So I'm sure there are quite a few people here who already qualify. And we have our own webpage out there. And we hope to attract people who look there and then hire us out for free so we can talk more about, you know, how we get to space and colonization and live in space, right? Which is once it's all. Was there a question online? All right, so check it out. There are presentations out there. You can ask for presentations, which are very, very interesting.
Masha, did you want to talk about the election at all? I'd let you come up here, but maybe we just talk about how people, what the process is, how people can, you know, sign up if they're interested, and then when we'll have them.
Okay, hello everyone. Our election has been delayed for a while, and that's kind of my fault. So I just wanted to announce that I will send you a form. So anyone who is interested in being on the board for the next year, you can fill up simply. That form is just your name, your family name, your NSS number, and your email address, and that's it. So for the next month, and I will leave that link open for people who want to get nominated for 1 month. And on our next meeting, which would be July 9th, we're going to have the elections. Those people who are in person, they can vote just by raising hand or something, or just writing in a paper. Those who want to do it online, they can just submit it online. And the positions would be president, vice president, director, secretary, treasurer, and here's another one too. So, yeah. So if you want to help us, join us, or anything like that, I would really appreciate it. But the only thing is that just make sure that your membership is not expired and is still valid, because those people who actually get the vote and we want to register over there, they should have valid number. And according to what I was Googling, that what should the numbers be? So it should be at least 5 digits. So if you have less than that, something is wrong. Probably you need to log into your account and check that number again. That's it. Do people at home have questions about this? I can log into my account and send it in the chat right now for the people who want to do it. And we can send, if you're subscribed to the North Houston Space Society's website, Nathan can send a link later on during the week. Let's see if there is any. No, I don't. Okay, Luck Patty said, I want to go to space station by NASA Hunch Mission Center, formally elected officials, so how? Probably, I'm not really sure. He assumes that if he applies through the Hunch program, he can go to space station. I'm not really sure you can do it. You need to be an astronaut.
Yeah, I'm not sure I get that question, but none of the Hunch students were able to get to the space station. A few were actually able to travel in the low gravity plane that they have there to simulate zero gravity. But you have to be at least 18, so some of the students didn't qualify to go up there. But none of them actually went into space.
Thank you. A zero-G flight at $10,000. So if you have it in your account, you can just go. Any other questions online, people? I think that was it. Sure. Do your thing.
And I don't mind enjoying so please tell us what you
ISDC, which for some reason I always transpose the digits and say it wrong, is the most amazing conference you could possibly imagine if, like everyone in this room, you're interested in the future of mankind in space. It was canceled the previous 2 years because of COVID. And so this year was kind of a catch up, and it was smaller. It wasn't as impressive as when I was there in 2018. But it was still, it was right at Reagan International Airport this year. And last year it was gonna be in Dallas. So we all could have gone, but unfortunately that didn't happen. I was very excited this year because being so close to DC, it's right there at the Air and Space Museum. I'll finish up with a little story about that. But if you ever get a chance to go to IDSC, it doesn't cost very much. You know, most of I won a writing award, so my entrance was paid, but it's like a couple $100. It's nothing. Most of the cost is the transportation. But if you ever get a chance to go, it is absolutely fascinating. You're going to presentations with people who, you know, who are dreamers trying to get money for projects, who are actually working at NASA, working on projects. It just runs the gamut. And to me, as a science fiction and science author, it's a work trip, so I can justify it every once in a while. But it's just fascinating, the different aspects of people, and they also have a competition there with a bunch of young people, a bunch of high school kids running around, doing art projects, getting involved in space. So it's just a really exciting time. This year, I actually won the Jim Bain short story contest the previous 2 years when we didn't have the conference. So we kind of had a catch-up presentation where we all got our awards. And we had a presentation by Dr. James Green, who is the outgoing head of science for NASA. And he gave us a fascinating presentation where he showed that we actually know now how to give Mars a magnetic field that can preserve an atmosphere. Everybody in this room probably knows that there has been speculation over the last 10 years that maybe you could build a giant generator out the Lagrange points, but it wouldn't really be practical. It would have to be so powerful. But they've actually done superconductor models that he was talking about this, where you could actually put low Martian orbit satellites in 4 places and shield the entire planet. And in the meantime, while you're working up to that, you could put 1 or 2 and shield just where you want to put, or just where you want to be doing work. So for example, you could have a satellite passing over and shield surface work crews, and as it passed overhead, they could then go down to where they have better protection. And I won't try to reproduce his presentation, but the upshot of it is we now have terraform Mars. It will just take thousands of years. So I think something went wrong. Hi. So, if we have a few $100 billion in a few thousand years, we can all live on Mars without spacesuits, no problem. It will be kind of stark, I'm warning you. But so my story about the Air and Space Museum. So I was excited to go to DC. I've never gotten to go to the Air and Space Museum, and it's closed. It's closed all year. What a bummer. So I didn't fly into Reagan. I flew into Dulles, where they have the Stephen F. Goodbar Hazy Museum. And you probably don't have any better idea who he is than I did. He is the guy who came up with aircraft leasing. And he is losing a crap ton of money right now because Putin has seized all his airplanes that were being leased to Russian airlines. But the US government got part of his money and they built this museum. And I decided to go, and I walk in, and what do I see but the Bell X-1 rocket plane sitting right there in front of me, which has been hanging up in the Air and Space Museum for my entire life, where nobody can get close to it. And I could have reached over and touched it, but there was a guy over there. Wouldn't have liked it. So if you get a chance to go. It's a fabulous museum. They have the Enola Gay, they have every kind of aircraft you can imagine. They have things from World War I. They have crazy experiment. They have the flying car, the only flying car that actually sort of kind of worked. They have it. Just an amazing, and they have a Blackbird. Although I have to say, the display of Blackbird at the Kansas City Cosmosphere I like better because it's overhead. You really get a sense for the size of it better that way. But yeah, just and they have a space shuttle. There's that, and an amazing collection of models of fully reusable space shuttles that we didn't build but might have. Just tons and tons of fascinating stuff. It is right at Dulles, and it's part of the Smithsonian, so it's free. Which is what I did. I flew into Dulles and rented a car and went to Reagan, and I didn't have any trouble. That's it. Oh, I did want to mention that the two main things that I got from the actual conference is there was a lot of discussion about space elevators, which for most of my life, and I guess most everybody here, space elevators are one of those things that we knew were possible in theory, but probably would never ever be built. We're getting very close now to knowing this is something that we could actually build, and it will not get hit by an airplane and wrap around the earth and kill millions of people. All the math has been done. We're not to the point of being able to really do the engineering to build it, but we're very close to the material science, and a lot of the problems have been solved. And the amount of money that you would save getting to and from space with the space elevator is such that when we can build it, I believe now we absolutely will. And what was the other? Oh, there was just.
The problem with that is that the thickness of the cable that you hold the whole capsule to go up and down is something like 1 kilometer. And that's the problem of material science, that they need to shrink it down. 1 kilometer thickness of the cable is.
In principle, it wouldn't be that thick, and but what makes it difficult is it would be thicker at the ground, and it would get thinner as it goes up. And there are all kinds of practical engineering challenges with being able to hold on to it and not damage it. But there are new developments in material science that are getting that a lot closer to being feasible. And then there's also, like I worked out about 10 years ago, that if you did damage a space elevator, the worst that would happen is it would just slowly drift upwards. It actually wouldn't come crashing down. And so if you were prepared for that, you could bring equipment into place and grab a hold of it and make repairs. So this is very, very interesting. Yeah.
So that it's a tape. It's longer than a convention. And that way it's getting back like a meter so wide. You still got 90% of the tapes. And so that kind of solves one of the engineering aspects of it. And the second is the material that they're talking about using is carbon nanotubes. And I bought a book on this subject here a couple of years ago at ISC about 4 years ago. And I think they were up to, they managed to make fibers that were 1/8 of an inch long. And basically, you want to build this out of a much longer fiber than that, about 22,000 miles long. But the rate at which they increase in the size of the fibers has been just doubling.
They can actually now, they're actually now making carbon nanotube tape in industrial quantities. It's not thick enough. It's too thick and doesn't have quite the right properties, but it's within reach now. One other thing I'll mention is if you ever get a chance to go to IDSC, you meet amazing people. At this conference, I got to meet Isaac Arthur, who's I have a little YouTube channel. Isaac Arthur is like big YouTube channel. That was really cool. When I went in 2018, I got to meet Rod Roddenberry, Gene's son. Like, let him use my phone charger. That was pretty cool. I got to meet Frank Drake of the Drake equation thing.
Yes, if you go to ISC, sign up to have a lunch session for an hour and a half, and they have a dinner session. And you end up at a table with people that are just like what he's describing.
And Peter Beck was the speaker, the big keynote speaker this year. I didn't get to meet him, but it was very, very amazing.
Next time you can pay $600.
Well, there's that.
I can buy anything, so just go.
Always true. Always.
Pick any astronaut you want.
It's rubber chicken. No, it's actually pretty good. The food is actually fair. But it's considerably cheaper. $600. Yeah. Like a $40 thing.
After you pay for your airfare, yeah.
You end up accidentally sitting at a table with a NASA astronaut, some scientists that on television, or people that the conversation.
I found myself accidentally on this trip. I found myself accidentally in a hallway with probably the world premier expert on colony ships, explaining why you can't actually build a colony ship that would be completely self-contained, because over the thousands of years it would take you to get to another star. You'll have things like the soil that you use to grow your plants will absorb carbon out of the atmosphere, and you'll have to, and all it, I mean, where else do you have conversations like that?
A very interesting latest NASA gave out some of the moon rock soil. They ground it up. They gave it to Florida University, and they tried growing plants in it, and it worked, although only for a limited period of time. Yeah. So that's the latest news as of like a week ago. That nobody thought you could grow actual plants, earth plants. Yeah, it was sort of that got up to a certain point. Yeah, and some people were saying that it's because the moon dust has shards. It's very sharp. All those grains have been worn down by wind and water erosion, and that the root systems were getting cut to pieces on the plants. They could get started, but then they just get by 1,000 cuts.
So you just have to take giant rock tumblers to the moon.
Exactly. There's a lot.
Soften up the edges.
Soften up the edges, and you can build yourself some domes and start growing food.
Any problem can be solved with a proper application of money and or explosives. Right. Yeah. So the one last year was called Reaction Time, which was published in Analog, which I would really like to get in the hands of Elon Musk, because he's doing this propulsive landing for the Starship, which he's talking about. I don't know if it will ever happen, but he's talking about using it eventually as, you know, a space liner, carry 100 or 1,000 people from point to point. And you don't really want to have a space liner that has no backup if your propulsive landing doesn't work out, whether you're landing on the ground or being caught. So I was thinking about that, and I was thinking about what I think is it Rocket Labs that's using the helicopter capture. And I thought, you know, what if you built kind of a really big drone out of with turbofan engines instead of propellers? And I did some calculations and said, you know, that actually would work, and it really would work. And so that's what that story was based on. And the one the year before that was recovering stable metallic hydrogen from Jupiter, which probably would not work. But it was a great fun story.
Do you have anything else you want to share before we wrap up? Great, well, stick around, let's hang out. I leave you all to hang out with each other online if you want. And anyway, but that pretty much concludes everything that we had planned.
How many people have not been to an ISDC? Okay, well, just to further Stuart's comments, the ISDC is typically held every year right around the end of May, not Labor Day, Memorial Day. And then it's oftentimes, Woodstock has traditionally been like a 3 or 4 day presentation. And the talking about hotel room, it's usually in a hotel. You got 3 or 4 conference rooms running continuously from about 9 a.m. to 4 p.m. with a break for lunch. And there is a different presentation every half hour or so. And each room tends to have, like, there's a morning block and an afternoon block, and they're broken up. It's like one morning in this one conference room, it'll be all asteroid stuff, asteroid mining, how to get there, what to do when you get there, what kind of market there is for asteroid mine materials. And then the afternoon will be like, in that same room, it'll be new technology, enabling technologies, new kinds of engines, new kinds of reaction systems, new kinds of environmental systems for keeping people alive in space. And then on another, I thought there was a whole morning session, and I thought there was going to be like 5 people show up for the whole morning. It was because I'm not really interested in legal stuff in space. And I wandered down there just for chuckles, and the place was absolutely packed. Imagine a room like this. People were standing on the tables in the back. It was because the author was, or the presenter was talking about what it would take for you to own a plot of land on the moon. And this isn't, and just how we had to have to thrash that out, the different, the English system of law, the French system, the Napoleonic Code, the two big legal systems that are used in the world today, and how they don't quite agree with each other, and we're going to have to thrash that out at some point. And how this could, dealing with all the existing and current outer space treaties, they don't say that you can't own land, a private person. They just say that governments have certain limitations on owning land. And so this really means that it is possible for people like us to own land on the moon. And boy, this was a really popular presentation. So there are some presentations you think they're going to be, oh, hot, you go in there, and there's like 10 people there, and it turns out to be, not so great. But you wander down the hall, and man, there's someone that you just said, well, this is kind of out there. I'm not even sure if I want to bother going. And it turns out to be one of the most exciting subjects of the day. And so I would highly recommend it. And definitely, as I said, it tends to be stretched out over 3 or 4 days. And also the lunch and the dinner presentations, there's usually a keynote speaker talking about some interesting aspect of space. But before the speaker comes up, again, it's a big banquet hall type room usually. And you just kind of wander in and pick a table to sit at. And then, wow, you end up with some of the most interesting people. And I mean, the conversation is about space, which we're all interested in. And these are people who are very well informed usually about some aspect. And it's great. You learn a whole lot of neat stuff. So I'd highly recommend it for anybody who hasn't been there before. Check it out.
And next year is
Yeah, right out. Driving is all that right for us. Last one that was held here in Houston was in 1999, and it was very well received. And it was really exciting. Everybody had really great time, and we had
What we can do is just go and click on open here.
Got tired of going to the presentations.
And then we can just say mirror duplicate, and then that way it's the same.
Behind the scenes tour of the various facilities. And that's usually true of most of the IXDC for the spouses who are not quite so interested in space. There are these side trip places that you can go to nearby, and it's usually like NASA related or rocket factories or just something really cool. Not just talking and PowerPoint presentation. It's real hardware inside, real manufacturing buildings. So very, very exciting. I definitely recommend it.
This is a ICS conference, which is next July from 11th to 15, I guess, or 15th, in Minnesota, St. Paul. I'm co-chair of space architecture.
Is this next month?
Yes. Yeah, for ICS session 502, all the sessions. So I think they're going to have some online presentations too. But the registration is very expensive. If by any chance I find the link that you can see it online, I will send that to that subscription list so that you can enjoy. But the topics this year's are very interesting. My session is Tuesday and Wednesday, so it would be space architecture and human exploration, psychochemical life support. All the Tuesday and Wednesday is about human in space activity. So EVAs, thermal and environment, I hope it would be fun. Okay, sure.
Good. Well, thank you all for coming, and I think we'll wrap it up, and you'll be around. And we can talk to people. Yeah, excellent. It's going good. I know, it's going awesome. Yeah, you know, it's like going to college, actually. Learning about fluid dynamics, heat transfer, and, you know, lots of details. All the different ways. Turn off the recording. I forgot I had that going, so that might be kind of